Hello and welcome to a new video. We are going to learn the second method for solving linear systems in this video, and it is called substitution. Before we get started, let's do a warm-up to practice a skill that we will use later on in this lesson. So solve the following equations for y. That means I want to get y by itself. Here's y in the first one. What we do is we look and see what else is on the same side as y, and then we use our algebraic properties to move them over. So for instance, this negative 3x, we can move over to the other side by adding 3x, because negative 3x plus 3x is 0. But in order to actually move it, right, we got to do it to both sides. So it's not that we just can pick up the negative 3x and move it over. We actually need to do the opposite of what it is so that it won't be on the left side anymore and instead will be on the right side. But it makes it change signs. So now we have y equals, I like to write the x first because it makes me think of y equals mx plus b. Technically though, you can write it in either order. And 3x plus 2 does not actually combine because they're not like terms. You have 3 times an unknown plus 2. And so since we don't know what x is, we don't know if we can add those together or not. Y is by itself, so we're done. That's all we had to do on this one was just add the 3x. Or add 3x to get the negative 3x to go away. B has a little bit more to it. We start off the same. We say, okay, here's y. We're going to move this 4x to the other side. We're also going to need to move the 2 in front of y, but we always save what's closest to our variable until last. So I'm going to take the 4x and say, I need to subtract 4x to get rid of that. So I do that to both sides and get 2y equals negative 4x plus 8. Then I'm going to say, well, what would I do in a normal equation, right? If I had 2y and I wanted to solve. I would at this point divide both sides by 2. And when we do that on the right side, it divides the negative 4x by 2 and it also divides 8 by 2. It's kind of like a distributive property, but for division, that both of them need to get divided by this 2. So negative 4x divided by 2, you divide the numbers and get negative 2, and you keep the x. And then 8 divided by 2 is 4. So there we go. We've solved that for y. Now, why do we need to know this? Why was this the warm-up I chose to give you? When we do substitution, we are trying to take one of our equations and make it have just x equals or y equals something so that we can take that and substitute it into the other equation. The blank here you would fill in with the word substitution, by the way, which is, I don't know, a challenging word to spell. There's a lot of T's that you can get carried away with, and that T doesn't really look like a T, and that's great. So one thing that you might use to help you is to think about what the word substitute means. So if you have a substitute teacher, or if you substitute something in when you're cooking, what you're saying when you substitute in the real world is that you're putting something in place of another thing, and that those things are considered close enough to the same that it works, right? So if I'm your teacher and I'm gone one day and instead there's a substitute teacher, that substitute teacher is not the same person as me. And they might be a better teacher than me, or they might be a worse teacher than me, but they are there to substitute for me. So they're supposed to still be a teacher, still be able to do all the things a teacher does. In math, when we use substitution, it's a little bit different just in that we're saying that what we're putting in is actually equal. No, they don't look quite the same, but they are equivalent statements. I feel like that's not how we use substitutions in the real world. Substitutions, usually there's something about it that is different enough that it's like, oh, that's kind of sad. Like if you have to substitute, if you had to substitute salt for sugar, that's not something you would do, right? But that would be a really bad substitution. But it'd still technically be a substitution. So let's take a look at how we're going to do substitution with linear equations. Also, just a note, we did graphing last video. This is substitution. This is going to be some of the longest math problems you've probably done at this point. Okay, so keep that in mind. I know they're long. You're going to see that they're long, and we're just gonna deal with that. So Our steps. Step 1, isolate a variable in one of your equations. Step 2, plug that into the other equation, and I'll show you how to do that, don't worry. Step 3, we're going to have something we can solve to get an answer, part of our answer. And then step 4, we're going to get the other part, because each of our answers should have an x and a y. And whereas with graphing, we found those at the same time because we could visualize where they were intersecting. Here, we're going to get our x and our y separately. So let's look at this. And it does say to use substitution. That doesn't mean that graphing wouldn't work. It just means that we're not practicing graphing. In this lesson, we're practicing substitution. So what I want to do is I want to stop and say, is one of these equations solved for a variable already? Because that would be really nice. That means that we don't have to do the first step ourselves. Well, the second equation here is solved for y. So here's what substitution is saying. If y equals 2x plus 18, then why don't we put that in place of the other y? We're going to substitute the 2x plus 18 in for the y that's in the other equation. Okay, so I'm going to rewrite the first equation, but when I get to where the y is, I'm going to put a parentheses around 2x plus 18 and insert it in, and then just keep writing the equation. The only thing I've done at this point is I've said, let me write the first equation again, but instead of writing y, I'm going to substitute what I already know y is supposed to equal, which is 2x plus 18. Then we basically solve this like a normal equation. Not basically, we do. We solve this exactly like a normal equation. We use the distributive property. We add like terms. We subtract things over to the other side. We divide. All the things that we've done with solving equations, we now can do that with this equation because there's only one variable now. So that makes it even easier than if we had two variables still that we were trying to deal with. And that was the goal, by the way. Our whole goal here was that we wanted to only have one variable so that we could actually solve this and get part of our answer. So mission accomplished, except now I have to actually solve the whole thing. So let's distribute to start off. There's not really much else we could do. Like there's nothing else that would be helpful for us to do before that. So negative 6 times 2x is negative 12x. Negative 6 times 18, well, that's an unfortunately large number. So 6 times 1 is 6 plus 4 is 10. So that's negative 108. Okay, then we look at this and say, what's our next step? Well, I have like terms here. Negative 4x minus 12x. Those make each other more negative. So that's negative 16x. And then we'd add 108 over and then divide by 16. I don't know if I said 16 or negative 16. I meant to say negative 16. So let's divide. So keep in mind this is going to make our answer be a negative number because a positive divided by a negative is a negative. And then we need to figure out what 128 divided by 16 is. Now, I'm going to be lazy about this, and I'm going to say I don't really want to divide 16 into 128. I'm just going to divide these both by 2 until I can't anymore. So 128 divided by 2 is 64. 16 divided by 2 is 8. Actually, now I can see what the answer is, right? 64 divided by 8 is 8. So our answer here is negative 8. So we've got half of our answer. We've got the x value. Now we need to find our y value. Now, we actually have two options. We can put this into the x in the first equation, or we can put it into the x in the second equation. And then we would solve for y. Both of those equations should give you the same value for y. But the second equation that's already solved for y will get us the answer more quickly and more easily. So I would recommend that we do that. Let's put the negative 8 right here where x is. We're substituting again. So y equals 2 times negative 8 plus 18. So that gives us y equals negative 16 plus 18. So y equals 2. So our answer is going to be negative 8 comma 2. There we go. That was a whole problem. If you're looking at this, you're probably like, wow, that was a lot. And let me tell you, these can be frustrating because if you mess up at any point along the way, right, that'll mess up the rest of the problem. And in fact, you could even get to the end of finding x and just mess up that last step, and then when you plug it into the other equation, you're going to end up getting the wrong y. So this is definitely one of those times where your teacher most likely will want to look at it and say, okay, maybe you didn't get the right answer, but why? Was it a simple math error where you said 2 times 3 was 8 and 2 times 3 is not 8? Or is it that you clearly don't know how to substitute? Because those are different, right? You're not technically being assessed on whether you can multiply or add correctly, although hopefully you can. You're being assessed on if you can use the substitution method. So hopefully that helps you persevere a little bit through this, knowing that it's not the end of the world if you're not getting a right answer every single time. That being said, you can check your answer to see if it's correct by plugging it back in, just like we did in the last lesson, where it might take us a little longer since these aren't solved for y. No, I don't think it'll take us that much longer. But if it's negative 8 comma 2, for instance, I can put it into the first equation. So that'd be negative 4 times negative 8 minus 6 times 2 equals 20. So we're saying 32 minus 12. Is that 20? Yes, it is. So it has to work for both equations. You can be pretty confident if it works for one. But if we really, really, really want to know for sure, we should plug it into both. So this is 2 equals negative 16 plus 18, which that is 2. So yeah, looks like we got it right. So that's awesome. You also might check, so I, on this section, am going to give answers that all end up being whole numbers between negative 10 and 10, partially so that you can know very quickly whether you have done the problem right or not, just by whether or not you get fractions. If you get fractions, that'd be bad. But check with your teacher or use your book or whatever it may be, because if it's likely that, like if fractions are a possible answer, then that's not a helpful cheat you can do of saying, oh, I got fractions, so I probably did it wrong. All right, let's look at another example. We've got 4 examples. Example 3 and 4 are a little bit trickier because we have to isolate a variable ourselves at the beginning. But go ahead and stick with it. As you do these problems, they should get faster, easier. That point where it starts to feel repetitive, like you've been doing the same thing over and over, is actually the good point to be in, because that means that you're starting to internalize the process and understand it better. So that's what you want to do. Is you may not want to, but you should try to get to the point where it's actually, it's gone past, it's satisfying to solve it and is actually a little bit boring. Okay, anyway, example 2. So this one is actually solved for x in the first equation, not y. And that's on purpose, because while we only solved for y before now because we were graphing, when we're trying to do substitution, if it's easier to solve for x, you absolutely can do that. So we already have x equals here. It equals 3y plus 2. The big thing is that if it's solved for x, we want to put that where the x is, not the y. Hopefully that makes sense, because we're saying x is this, not that y is that. So this is going to be 2 times 3y plus 2 minus y equals 4. If you do put it in the wrong spot, you should hopefully notice when you're like, wait, why do I have 2 variables still? Because it's helpful that we have 2 different y's, because we'll be able to combine those and solve. So same kind of process as the last one. We're going to distribute. So 6y plus 4 minus y equals 4. We're going to add our like terms together. So the 6y and the negative y, which is really negative 1y, combine to be 5y. And then we have a 4 on the left that we need to move over. Now something interesting happens here, right? Because 4 minus 4 is 0. And you may be thinking, oh, 0, division, stop, no, don't do it. But 0 on top is fine. It's okay to get 0 on top. 0 divided by 5 is 0. If you have 0 pencils and you have 5 people who need pencils, they're each getting 0 pencils from you because you don't have anything to give to those people. So that's okay. That's how that works. Y equals 0. Now let's take that and plug it back into the first equation because it'll be easier. Although both of these are pretty easy since y equals 0. X equals 3 times 0 plus 2. So 3 times 0 is 0 plus 2 is 2. So x equals 2. I don't think I pointed this out on the last example. We're going to write our answers as points 2 comma 0 because that's the way we write our answers to these. There's definitely things in mathematics that we do this because this is how everybody does it. And there's things that are like that for English or other subjects as well. So this is one of those things that the answer to this is the point where the 2 lines we have intersect. And so we make our answer look like a point by putting x comma y with parentheses around it. So there you go. Example 3. Now, on example 3 and example 4, we're going to have an added step to start off because neither one of these equations are currently solved for a variable. It's our job to solve for a variable. And I purposefully am giving you questions that it's not so bad to solve for a variable, and that there's a good thing to pick to solve for. Because I could have been mean or something. Maybe mean isn't the right word. You could end up with a problem that is actually really hard to use substitution on because it's really hard to solve for a variable. It gives you fractions and is just not very pleasant to work with. And that, by the way, when we talk about which method should you use, that's one of the things that would come into play here. But in this, if I am looking for what I want to solve for, I need to say, is there one of these variables in one of these equations that doesn't have a coefficient? Coefficient is the word for the number in front. So here's our coefficients. We've got 7, -2, 2, and 1. The easiest thing to solve for is going to be the thing with a coefficient of 1, if there is something with a coefficient of 1. So we want to solve for this y right here. And the reason is that if we divide everything by a number, then that's where we're going to get fractions. And in fact, any of the other letters we try to solve for in this problem will give us fractions. No, we just avoid fractions if we can. To solve this for y, we're going to subtract we're going to subtract 2x from both sides and get y equals -2x minus 4. We're going to take that and we're going to plug it into the other equation. Now this is important because I think it was fairly obvious in the last one that which one we needed to plug into, maybe less obvious here. Because we used this equation to get y equals -2x minus 4, if we plug it back into that equation, it gives us an incorrect situation. We have to use the other equation now. So I'm going to write 7x minus 2, and then in parentheses, I'm going to put -2x minus 4, and then that equals 19. I'm going to solve this. Like I said, the more of these you do, the easier it should get. -2 times -2x is a positive 4x. -2 times -4 is positive 8. Now we're going to do 7x plus 4x, which is 11x. And then I'm going to subtract the 8 and get 11x equals 11. Divide both sides by 11, so x equals 1. Now I'm going to take that and plug it in. Again, what I solved for y is going to be the best place to do that, the fastest way to get my answer. So -2 times 1 is -2, minus 4 is -6. So our answer is x comma y, which is 1 comma -6. By the way, if you were to encounter a problem like this that did not use x and y, and you get to the end to the answer, or like, how do I write this as a point if it's not x and y? The convention is, or accepted practice is to do it in alphabetical order. So if you had a and b, you'd use a comma b, for instance. Just to throw that out there in case that in case you come across something with different letters. Example 4. So this is the last one. If you're feeling good about it, pause the video, try it yourself, start it back up when you're stuck or when you have an answer. But also just trying to do this in such a way that it feels more like I'm holding your hand instead of just talking at you. So like pausing the video to make sure that you're keeping up, or skipping around, things like that. If you have a question and I don't answer it, you absolutely could leave a comment and I will do my best to answer it. And let's do this. We are looking for a variable that has a coefficient of 1, or if that's not possible, a coefficient of -1 would be the next best thing. So there's actually two of them here that would not be that bad to solve for. In the first equation, this x has a coefficient of 1, so I'd say that's our best thing to do. But if you didn't realize that, solving for the y in the second equation wouldn't be a terrible idea. So if I want to solve for this x, I need to subtract the 5y over to the other side. And so that means I have x equals -5y plus 1. Again, I could put that in the other order, 1 minus 5y, and that would be fine. We are going to put that in for this x right here in our other equation. And then do all the things we've been doing. Like I said, this hopefully at some point you're used to it and it starts to feel repetitive, but also hopefully you are consistently getting it right. Let's see, 20y minus y is 19y. Well, that doesn't seem great. But then whenever I add the 4 over, I get 19 on that side. So I guess that's okay after all. And then we divide both sides by 19 and we get y equals 1. We take that and we plug it back in for our x. I mean, we plug it in for y so we can get x. That's what I was trying to say. X equals -5 plus 1. So x equals -4. This is -4 comma 1. And that's our correct answer here. So that was example 4. Thanks so much for watching. I hope that you enjoyed this video. There's definitely more to come next week, or maybe it's already there depending on when you watch this video. I like systems of equations. Hopefully you will like them as well. And I will see you in the next video. Don't forget to subscribe and like and all that stuff. Bye.